Welcome to the FedEx Institute of Technology podcast, where innovation meets insight. As the University of Memphis's hub for research and emerging technologies, we bring together experts, leaders, and change makers to share ideas shaping the future of technology, business, and society. Thank you for joining us. Let's get started.
We go to the best speech, which is last, because you always save the best for last, with Dr. Seth Dobrin. Couple of interesting things about Seth. I'm going to say at the end of the speech, you're going to really be enthused about the future, not the distant, fuzzy future, about what's happening today in the near future. Dr. Dobrin's got a great, deep and broad experience base. He's got a PhD in molecular and cellular biology, and I don't. Very, very, very impressive. One of the interesting things that Seth and I have in common is we both crossed paths at Monsanto and Bayer, not at the same time. But no matter what you think about that company, I'll tell you that nobody knows more about corn and soy than this company. So if you think about no one knows more about transportation than FedEx, no one knows more about corn and soy than the combined Bayer-Monsanto team. And without them, frankly, people die. But that's a whole other issue we'll talk about over a beer sometime. But the reason that that organization is so good is in large part to the work of Dr. Dobrin. So setting up the machine learning models and the data architectures to support the plant genomics. That company knows more than anyone on the planet. And it's due in large part with Seth and the work that he's done with the great scientists there. Third thing you need to know is that Seth was the first chief AI officer for IBM. He consults multiple countries on their AI strategy. We had some really interesting drone discussions last night. I won't steal any of your thunder, let you go forward there. And he's the CEO currently of two companies. So please join me for welcoming Dr. Seth Dobrin to be our final keynote speaker of the day.
All right, thank you. Monsanto also made up for their rap for treating their employees probably better than any company in the world. So that was another good thing for working for them. Whatever my title said in the agenda, it's different now. It usually happens with me. So today was a really good day. It was a really interesting day. There was a lot of stuff that everyone talked about throughout the day that I think was extremely relevant for what's going on in the world with AI. And one of the things I liked about this event was it wasn't just about AI, it was about the intersection of AI and cybersecurity. And I think for those of you who are in cybersecurity and at an AI conference, you are probably in one of the fields that actually have just job security, at least for the next couple of years. And so this is a really important place to be right now. And one of the gentlemen, I was actually moving across to come down here. I didn't see who said it, said that AI is not going to take your jobs. I think in 10 years' time, he's right. In the next 2 years' time, I would say that probably 80% of software developers are going to lose their jobs. If you're a software developer, you better rethink about what you're doing, or you better make yourself invaluable. There's lots of other high-paying jobs that are going to see a similar fate. And so as companies, as a society, we need to think about how we're going to deal with 80% of multiple high-paying jobs going to be out of work because we may be saving money, which we think is going to increase our margin. But if we don't have customers who typically make a lot of money, where are we going to get that money from to save margin? So just a thought based on some of the conversation we had today. And so, we heard about, one of the things I like listening to David about, is I always learn something when he talks. So we heard lots of stuff today, tying everything from, international policy all the way through to cybersecurity and AI, as well as building community and things like that around hacking, around, how do you tie people together locally, around building startups. And I think one of the good things about this ability to reduce headcount and things like software development is it also enables things like rapid innovation for entrepreneurs. You're starting to see a lot of single entrepreneur tech startups or very small entrepreneur tech startups that can rapidly build companies to product capabilities. And second half of the presentation, I'll talk about one. And the one I'm going to talk about is just one example I know of that I'm very close to. I know of many, many other examples I'm close to, but further away from. And I think over the course of the next, year, 2 years, 3 years, you will see multi-billion-dollar companies that have less than 200 employees. Think about that. Multi-billion-dollar companies with less than 200 employees because of AI. All right, so now I'll actually get on with the talk. So, as AI becomes more powerful, right, are we actually losing control? So how many of you have experienced an AI system that was making a decision that you couldn't understand? Anyone? Raise your hand. Yeah, I think everyone has, right? I mean, when you get a mortgage, do you understand how the AI system that's making a credit decision about you is making that decision? Have any of you ever asked? Because when you get a mortgage or apply for a credit card, it's an AI system. No? All right. Anyway, AI is driving decisions around us, and I bet you've never even thought to ask half the time, right? But you should. And so, we are in the AI revolution. We actually have been for about the last 6 or 7 years, probably even a little longer than that. The problem is, it's been a very slow revolution until about November 2022. Then people started getting excited about it. It was still slow for about 18 months after November 2022. Companies started talking about it a lot. People started getting interested in it. And it wasn't until recently that you started to see people say they're getting value from it. If you look at the stats, 78% of organizations are using AI in 2024. That's up from 55%, what they mean by using, right? That's a whole conversation. There's 59 new AI regulations. That's double from what it was in 2023. That's just in the US. And then you're seeing companies go from experiments to mission critical in 18 months. Now, these experiments to mission critical are in a very small subset of companies. And that's what you're seeing with AI adoption, where you get rapid AI adoption. It's in a very small set of companies, and these small set of companies are the same companies that were very successful and have been very successful with machine learning, right? These are companies that have been successful for the last 6 years, and the other companies, everyone else, is still struggling with the same thing, which is how do we drive transformation? How do we connect this to business value? And how do we do it successfully in the organization? Now, it gets even more complicated with this new type of AI, because now we have AI, generative AI creating this content across all different modalities. We have, the capability to do predictive analytics and cybersecurity. We have autonomous decision-making happening across all different systems. We have the ability to do, this AI-powered transformation. And we can even create completely digital worlds. Right now, we're getting into things we were talking about 4 or 5 years ago with metaverse. But now we can actually start creating true digital worlds as we move beyond these current transformer models, which is what the T in GPT means transformer. As we start moving to next generation architectures, you're getting into types of AI where you can actually model the whole physical world. And you can start representing these things. Now, this comes with some challenges because if you can actually model the whole physical world, imagine all the scams you can do, right? So how do we do that safely? And how do you do this in a way that you can know when you're interacting with the physical world or you're interacting with the digital world? So these are the types of things that we need to start thinking about. And now we get into this whole other conversation about this great scaling fallacy, right? And we get into this whole phallic conversation. I use fallacy intentionally because we're getting into this whole mine is bigger than yours conversation between all these AI companies, right? So you have this race towards bigger and bigger and bigger and bigger of these generative AI systems. And bigger is not necessarily better. In fact, I would argue that bigger is worse in most conversations. If you're an enterprise and you are trying to implement these large general purpose language models, in almost every instance, a general purpose model is not going to serve you. In fact, in almost every instance, a very large general purpose model is going to be counterproductive for you. It's going to be costly. It's going to come with a lot of baggage. It's not going to be specific for your enterprise. It's going to cause a whole lot of other problems because of those things where it's going to start hallucinating more. And even if you start doing things like RAG or like fine tuning, those create additional problems. And so bigger is not better. They also talk about they're getting bigger so they can reason. Doesn't really reason. It's as smart as a PhD. Not really. It depends on which PhD. I know a lot of PhDs that are not very smart anyway. So I know a lot of people that don't have PhDs that are a lot smarter than PhDs. And so, so what is it? So, and when they say reasoning, what they are talking about is mimicking certain types of thought processes. And it's not really reasoning, it's working through things like math problems. It's working through coding. It's understanding coding. And yes, it does this very well. And it's not to say I don't use these systems. I use generative AI every day. Incredibly powerful tools. In fact, I would say the best tool out there is this tool called Manus. It used to be a Chinese company, now it's a Singaporean company. I like it for a variety of reasons. One, it's incredibly powerful. Two, they're very transparent with their terms and services. I always like that. But I just think it's the best one out there for most things. If you're doing coding right now, GPT-5 is. If you're doing coding, you just have to go with whatever the new one is because it changes every day which one the best one is. And so, I'm not saying not to use large language models, but if you're in an enterprise, you are not going to get ROI in most cases with a large language model. You need to take a step back and look at what these transformer models were built for. What were they built for? Again, the T in ChatGPT stands for transformer. It was originally built by Google to translate one language to another. So if you go back to 2018, you think about translation apps. The best application, the best place to go to on the internet, because we didn't have apps on our phone really then, was Google Translate. Why was that? It was because they developed a transformer model. It was designed to translate, to do one task, translate language A to language B, one specific task. If you use these transformer models to do one very specific thing, it is excellent at it. In fact, back to small founder teams, I know there's two guys that built a startup, still two guys, a company called Data Biomes. They developed nano models, like 2 million to 8 million parameter models. These models on the tasks they're trained on outperform GPT-4. They have like maybe a 0.01% hallucination rate on those tasks. Those are the kinds of things you can do. Very cheap, $1,000 a model. right? I mean, that's incredible. At least that's what they charged last time. They don't quote me on the price, but right. And so, but it's like that kind of range of price. But you're going to use for them, you're probably going to use 100 models, right? So I mean, you're going to use a lot more models, but at the same time, it stays on your premise. You can run them on your phone. You can. I mean, I don't have any interest, by the way. I don't own stock in them. They're just friends, right? I don't have no financial interest in them. And so think about those types of things, or even if you're going to go to a large model and you're going to build a model about your company. That is something that's valuable. And you do it, someone said earlier about distilling, right? You talk about DeepSeek. DeepSeek, or David said this morning, DeepSeek absolutely did distilling. And you should use a system like distilling to build your model. Use Llama or use DeepSeek to train a new model about your company. That's a great use of these large models. Take their model and you train a new model with it. But you have to use an open source model. You can't use OpenAI. Well, you can use their new model to do it. But so those are the kinds of things you can do with these models to help move across. And so I kind of went into all these things. But when you look at it, right? So think about data centers consume 4% of the world's electricity today. Right? As an enterprise, you could cut down on these costs. These are the types of costs that you can cut down on just by moving away from these large models, or by not engaging with them, because most people aren't doing this. Plus, you move all of that data that you're shipping off to OpenAI, to Anthropic, to Google, to wherever you want it to be. If you're a multinational company, you've now solved all these data sovereignty, data localization issues. You can run them wherever you need to be. You could build culture-specific models. You can have all of these challenges that you're thinking about, or your data privacy officer is thinking about right now. How do we solve them? They're solved by moving to small models, right? This is a challenge that makes it so much easier. This solves a lot of the challenges with these large language models. And so, again, the black box problem, I don't think this is anything that anyone in the room hasn't really thought about. Small models don't fix this problem, though. We still really don't understand how transformer models work. We probably never really will. Anthropic is working on something called interpretability. Interpretability will help get us some sense of what's going on in the model and how it got to a decision. Well, I don't have the stat I have in there is a little bit further down. But if you look at the amount of money, oh, here it is. It is at the bottom here. If you look at the amount of money that's being invested in safety and explainability compared to the amount of money that's being invested in bigger is better in this phallic race, you have 0.003% is being invested in safety compared to what is being invested in building bigger models. There's a problem with that. So how do we break these paradigms? What are the types of things that we need to start thinking differently about? How do we kind of move beyond this? And what are some good examples? So when we look at humans, so humans build mental models of the world. And transformer models and traditional AI systems, they do pattern matching. They don't truly understand things, right? I talked about, ChatGPT and all of these other things don't truly reason because they don't really understand. They're just getting really good at predicting what's next and being able to reason by predicting a whole bunch of things that are next simultaneously. And, understanding how to do all of this through embodiment, and safety at the same time. So embodiment is physical, interacting with the physical world. So how do you use interaction with the physical world to help make AI safer as well. So how do you learn from the physical world to help drive AI safety as well? And so this is moving to new architectures, something called a world model, and combining this with small models, you get to something that more closely resembles the human brain. And David and I did not have a conversation about this morning, I promise. But when you start thinking about it, talk about data centers using 4% of the world's electricity, your brain operates on a Caesar salad or a hamburger, right? Now, why is that? Because every neuron in your brain is not operating all the time. Yes, there's a very low basal level of energy it consumes, but it really only fires neurons that it's using. Can we build AI systems at scale that do that? So there's a known architecture called neuromorphic compute that does that. That's starting to take off. That's really valuable for some specific applications, typically edge applications. But this whole concept of can we model the whole world? Can we do that at a way that scales? You guys have probably heard, you guys know Fei-Fei Li. Everyone know who Fei-Fei Li is? And you've heard of her company called World Labs. So this is what she's trying to do. And so what are world models? That's what I'm talking about here. These are internal simulations of the world. And so these are basically, you're taking an AI system and you're modeling the whole world. So how do you simultaneously model everything that's going? So imagine creating a simulation of this world and everyone in it with the accuracy of physics. Being able to predict, thousands of times every possible thing that's going to happen in this room. Right? So could anyone ever have predicted that the day would go on time? Right? Every scenario. So think of like the multiverse. That's essentially what these models are intended to do. And you can, do compressed representations of environmental dynamics, of time, and you learn through these interactions, not just data consumption. So you build the model, and then you interact with it. And you say, I want to do this, I want to do that. It's not a constant training. It's once the model is built, you interact with it. And I'll show you some examples. Now, there's some different types of these models. So what Fei-Fei is building at World Labs, there's a company called Runway ML. Runway is great. You can go on Runway ML and you can create all sorts of images and videos. It's fantastic. So if you need image, don't go to Midjourney, don't go to Stability. Stability's starting to do these well, go to Runway ML. Another one of my favorite tools. What they're doing is they are taking images and video, and they're trying to learn about physics from watching videos, right? Some inherent issues with that. And they're teaching a transformer model about this from those things. So their models are probabilistic. And so let's talk about the difference between world models and transformer models. And how businesses should think about them, because we're getting to the point now where we'll be able to start using them as companies. I think, and by large language models, I mean going all the way down to small models too. I should have just said transformer models, not large language models. I think, companies should use transformer models. Despite all the negatives I said about them, there's a whole lot of value you can get from transformer models in general and domain-specific, company-specific large language models too. A lot of value you can get from productivity, a lot of wins you can get in that space. World models you should start looking at in the long run. If you are building a product of any kind, you should be looking at world models. I'm telling you now, I'm being a little self-serving, by the way. What types of strategic applications for each? From foundation or from transformer models, this is talking about knowledge work automation, right? I talked about developers being out of work, right? Their jobs being impacted. Accountants, paralegals, any knowledge work is at risk of automation through foundation through large language models or small language models or things like that. These models are very good at replicating high value knowledge work. Those are the types of things. World models are really good at product development. So how can we get better at product development? So how can we do this build, test, refine cycle before ever, design, test, refine before ever building a product? So imagine being able to build, design, test, and refine a drone before ever building a drone, or a whole airplane, or a whole space station, or a whole city. Those are the kinds of things you'll be able to do. Some of them you can do today. When you think about implementing them, right? LLMs, you can start doing that today. The cost is relatively low. I thought, oh, I had to correct it on my slides, not here. You know, LLMs, you go down to small models, you're looking at $25,000 to implement, to $1 million. World models is actually probably down to 50K to 10 million plus. There's varying levels of accuracy you need, various levels of skills, but there's also varying levels of competitive advantage for your company. Just about everyone's trying to use LLMs right now. World models, not many companies are starting to implement them. It gives you some competitive advantage. Here are some different use cases. Again, for both of them, this is just some. But the point is, you should be looking at multiple different types of AI. Don't just focus on large language models. Certainly don't just focus on OpenAI or Anthropic or Google. Focus on world models. Focus on traditional machine learning. Focus on Bayesian learning. Look broadly. It is going to be not a multimodal world. It is going to be a multi-model world. That's really important. Now, the interpretability advantage. We need to make sure we embed safety in everything. Part of being safe is being interpretable. Should be transparent. The reasoning process you're going through should be transparent. The outcomes should be predictable. There should be human-like decision-making pathways. We need to make sure we understand and we can follow a thought process of an AI, and decisions should be traced back. You should be able to basically have provenance on a decision-making process, right? You should be able to follow the lineage and the provenance all the way back through. Now, when you look at cybersecurity, the digital twins, right, the physical systems, these are the kinds of things that world models can do. So we're talking about cybersecurity today, talking about breaches, right? World models, a network is a physical system. You can actually build a simulation of a network, and you can actually model different types of scenarios. You could basically simulate what it looks like for a breach, and you could then monitor for what those breach looks like. You could also have your people practice, and you can do, there's all sorts of things you could do this all the way through to physical systems. I talked about this a little bit already. Now, there are a lot of challenges with this, right? This is a brand new technology. There's computational complexity. One of the reasons this technology has not really gone anywhere till now is there's tremendous computational complexities to this, as you can imagine. You're trying to learn from the visible world. This is incredibly challenging. So you're trying to learn physics from watching things. That's really hard. How do you verify that you're right? Also very hard. Now, how do you scale this? So scaling these models, we're having a big enough time with energy right now, scaling traditional transformer models, now trying to do this with completely visual models, models that think like humans. You're talking models that are orders of magnitude bigger than ChatGPT. The number of parameters is actually smaller, but the size of the model is actually bigger, even though the parameters are smaller. And we're on the actual research frontiers here. Now, with that said, though, when you think about this, by building these models, AI can actually design a better world.
For centuries, we've designed the world the only way we knew how: build, test, fail, rebuild, over and over again. But sometimes, failure is more than just a setback. 2 Boeing 737 crashes resulted in the loss of 346 lives. Astronauts stranded in orbit for weeks. A single blackout in 2025 left 60 million people in the dark for 17 days. Billions lost, decades wasted, lives broken. What if it didn't have to be this way? What if we could test 1,000 designs before building just one? What if a power grid could adapt before it fails? What if we could simulate the future before it happens? There is a system that doesn't wait for failure, that doesn't guess, it simulates. That doesn't just accelerate design, it redefines what's possible. Arya. It models the real world, with real physics, real constraints, and real consequences. Arya doesn't wait for failure. It sees what's coming and reshapes the outcome. In aviation, it tests thousands of designs before one ever leaves the ground. Space missions aren't just planned, they're rehearsed. Every maneuver, every variable, tested before ignition. In medicine, discovery no longer starts in a lab. It begins with millions of virtual trials, run in parallel, guided by AI. Power grids don't react, they adapt. And cities, they're designed for the needs of the next generation, not the limits of the last one. Failure is no longer an event. It's a possibility, already explored, already avoided. What if AI could design the world? It can. It already is.
So I talked about AI replacing developer jobs. And then I talked about AI being able to accelerate entrepreneurship. So I have a friend in Poland. He and I have been talking about how you could use small models. He's an astrophysicist. And how you could encode physics into the base of world models and not have to train it from images. And the end of June, beginning of July, he and I decided to form a company. And what we've done is we've actually encoded physics into a world model. So we didn't have to train the world model from images. So the model knows physics. So we don't have to go through that exercise that World Labs is having to go through. And we actually built, so that drone that you saw, that drone image, that was actually a project we did for the Polish army. We did that 2 weeks after we founded the company. We have 6 developers that are working with us. We have 2 customers now. Well, we have 1.5 customers besides the Polish army. We just signed a deal with NASA. We've only been in existence for 6 weeks. Right? That's so assuming we didn't get customers, the customers are from me having contacts, but we built a product in 6 weeks, like a fully functioning product. That's crazy. A data biomes company, 2 founders, they built a product, fully functioning product in 6 months. There's another company called Viox. He built a fully functioning product. He has 12 customers in a year, single founder. He got funding before he had, I think he had like 4 or 5 customers before he got funding. But this is, I mean, I could go on and on with where you have founders where there's 1, 2, 3, 4, 5, 6 people that are getting to ridiculous stages before they're getting funding, before, this is, things that you never would have imagined before that are kind of the opposite of what I was saying from, what's happening in the big corporate world. I don't know that it's going to make up for what you're seeing on the corporate side, but it's a kind of innovation that is impossible. Now, one of the things that's driving this kind of innovation in the startup world that can't quite happen in the corporate world yet, but will eventually make it there. One of the reasons that all these startups are able to move so fast is things like Cursor, which you can take advantage of, but not quite to the same level we can, is every time we all deploy new code, we throw away our old code. There is no technical debt in a startup if you're doing it right. We can do that. You can't. Right? Could you imagine throwing away your entire code base every time you deploy new code? Right? We can handle 99.9% accurate, 99, even just 99% accurate code. In most cases, you can't, because your code bases are too big. Right? Most of our CI/CD pipelines are completely automated. We don't even look at it. You can't do that. Right? So, but those are the types of things that in 6 months, a year, 2 years time, probably you'll be able to think about. Probably can't throw away your entire code base, at least not existing code base. But as you're building new applications, those are the type of things you should start thinking about. How do I build new applications where I can throw away my entire code bases? Or I should build code so I can. No file should have more than 1,000 lines of code. That should be a rule. Seriously, in Cursor, we have a rule built into Cursor. No file can be larger than 1,000 lines of code. These AI coding systems can't handle anything larger than 1,000 lines of code. Don't do it. It'll break. It'll start messing up. It'll go awry. Plus, it's just good coding practice. And then when you build a new one, throw it away, start over. Who cares? Right? It's only 1,000 lines of code. If you're 99% accurate on 1,000 lines of code, it's no big deal. That's why we can tolerate it. If you have a 10,000, 100,000 line of code application, you can't tolerate it. We can tolerate it. So as you're building new applications, think of things like that. Think how you can build using AI and following the rules that these companies, these startups, should go on Reddit for code for some of these Reddits for these AI tools. Go on Cursor, join the blogs, go see all these rules that these startups are using and how they're building their automated pipelines, because they're all automated. No one is looking at their code before they deploy it. All the testing pipelines are automated. Now we all have, hardcore test scripts that we run. It's all, and we look at all the metrics and everything, and no one shares what our metrics are, right? But, unless you're really good friends with them, but no one looks at the code before it's deployed. So what is safe AI? Oh, sorry. The other thing with that video is every simulation that we run is embedded with 3 things. It's embedded with made by Aria. You can't see it. It's embedded by made with Aria. It's embedded with the company that made it, and it's embedded with the user ID, so that you cannot then generate a deep fake with it. Because the physics is better than 99% accurate, or 97% accurate now, we will get it upwards of 99% accurate. You will not be able to tell a deep fake. The reason you can tell a deep fake today is because the physics is not perfect in it. Once the physics get perfect, you won't be able to tell a difference. So we're making sure that there's embedding in it that completely makes sure that you can identify it. So, that's something that we're doing. The other thing we're doing, and I'm probably might get through the rest of my deck, which is fine. The other thing we're doing is world models can actually because they look at the world the same way humans do and actually can reason the same way humans do, and this is all built on small models too, as I mentioned, we actually think that we could get to the point where we will be the first fully autonomous company. So one of the things that my co-founder Lucas and I are doing, and our lawyers are still working out exactly how we're going to set this up, or we know how we're going to set it up, but he's just working on legally how to structure it, is we're setting up a DAO, so a digital autonomous organization, parallel to our Delaware PBC. And every employee in the company that ever walks through the doors becomes a member of that DAO. And they never, unless they are released for cause, they never exit that DAO. And that DAO owns 5% of the company. And in perpetuity, they get to reap the rewards of the company. And so the whole point of that is, even if they resign or we let them go, like let's say we start downsizing the company and the company value goes up, the whole goal is for them to keep getting paid from the DAO. So as soon as they're released, the DAO starts paying them. And the expectation is that over time, the value of the DAO will go up, and they'll go up. And then our 5%, and then 10% of our net profits are going to get paid to the DAO once we get over a certain amount of profitability. And so we will be paying money into the DAO as well. And so we're trying to set a model for how can you be true to your shareholders, but how can you also be true to the people who have contributed to you getting to the place where you need to go. Because as I said, if we don't make sure that humans are participating in the economy, we're not going to make any money. So we have a dual purpose of making sure that we become the first fully autonomous organization, but at the same time, making sure that the humans that help us get there have viable way of living after that. We're doing that same thing. And we're also trying to see, we're also going to be providing benefits to the employees through that, at least in the US, because there's no benefits if if you're not in a company. So those are the types of things we're trying to think about, is how do we do both simultaneously. So we're also looking at how do we structure in a way that's benefit for everyone moving forward. So I'll stop. I'll leave my promotional slide up there and I'll stop there.
Oh, hi, Mike Saltzgaber from Savamo. I wanted to go back to a point that you made about AI being explainable, that the outcomes ought to be, the thought process ought to be explainable. So the reference I had was going back about 5-10 years when AI and DeepMind was still looking at trying to master gaming, and we're looking at building AlphaGo. And the system started making moves that they called them 10 Dan moves, because nobody on the planet could understand what the AI was doing. So if that is true for a gaming system, then how do we look at AI models that are making inferences and reasoning that would be par to or higher than our ability to comprehend the explanation?
Yeah, so one of the reasons so before I started this company, I had my own consulting company that was successful, and I have a venture fund that I'm also a partner in. And I stepped back from both to join this company. One thing I didn't get to is this technology is completely deterministic, 100% deterministic. Because it's deterministic, we can explain it. And it's got complete provenance. And so through this, that's how we can explain it completely. Now, we need a program to explain it because it's so complex, but we can design a system that can explain it. And it's not an AI system, it's just something that will help walk you through the system. So we don't need another AI to explain it. We just need to write some code that can answer your questions or help show you where to go to look at it. So you need a deterministic system or a pure statistic system to explain it. These complex, deep learning systems, you can't. This is a complex deep learning system, but it's a deterministic one. And because it's broken down into small models, we know which small model contributed to it. And there's no model that's bigger than 8 million parameters in the system. Some of them are even just small individual contributions, like the temperature. And so, they're very, very small models.
I think that's me. Hey, cool. Great talk. Thank you. Very interesting. Lots to think about. And I'm not going to monopolize with all the questions that came up. But one of the fun topics that came to my mind, especially when we were talking about the multiverse and modeling reality broadly, a lot of that's been the promise of quantum computing for quantum understandings in general. So wondering what cross studies y'all have had with that.
Yeah, so my co-founder and I have a lot of fun conversations about that. And there was an article in Scientific American saying that quantum theory is a bunch of bullshit. I think that was the quote on the title. And so, yeah, so the whole concept that two molecules can be in the same place at the same time, there's a lot of debate whether that's even true. It's just, do we truly understand what's happening? And so I think a system like this could help us understand that, if that's true or not, right? And so really what the guy, I forgot the guy's name, but he's like one of the, he's won every prize in physics. So it's not like just some random person saying it. I forgot his name. What he's saying is it's a lack of creative thought that's preventing us from understanding what's really going on in quantum, kind of like the AlphaGo instance, right? It's a lack of creative thought that prevented us from understanding that. So a system like this could theoretically help us do it. Our system understands quantum as well as humans understand quantum today, because we base it on physics, on laws. There is no quantum law to explain it on, so it just understands quantum as well as humans do. Now, we use AI to train it as it learns. We don't have any quantum projects. We probably won't in the near future, so it's not going to get any better. And it bases it on what it learns in the real world. There is no quantum physics in the real world as we understand it today, so it won't get any better from that. So I got nothing for you. That was a long way of saying that.
Hi, a great presentation. I'm quite excited to see how the future unfolds. The quick question for you is, as researchers, what are some things we should be looking at as academic researchers?
From what perspective?
Particularly from, let's say, systems and management perspective.
Like business management perspective, or, I think there's a couple things. So I think one is helping businesses understand how to truly get ROI from innovation in general, and how to measure it. I think there's a lack of understanding of how do you really measure ROI from these systems. And this is particularly true when you look at revenue generation, right? Cost savings is relatively straightforward, but when you add innovation and you're creating new revenue, that's really hard to quantify. So helping credit, how do you quantify that? I think that's really challenging unless you're in a kind of, organization that's used to do. Monsanto was a unique place where we were able to get, kind of agreement on how to quantify that. That was a very unique place. There's very few organizations that I've seen that have been able to even agree on how you're going to quantify that. Like maybe 5, like seriously. And so how do you do that? Number one. I think number two, it's important to kind of get a system of systems thinking and stop thinking locally, right? Most businesses think business unit or organization and business unit. They don't think corporation. And getting organizations to think corporations and then think industries. And so even in a corporation, they have to think system of systems, and then academics should think industries. And I think we need to start kind of making that extrapolation, and academics are a core part of that.
All right.
Thank you.
All right. Thank you very much.